Can you see the whiteboard? Can you unmute and tell me if you can see the whiteboard?
Yes, ma'am.
Okay. So the topic that I'm going to take is equivalence of context-free grammar and PDA. Equivalence means that you can convert CFG to PDA and also PDA to CFG. Okay. So today we'll take one easy topic, that is how do we build a PDA from grammar. Means they will give you a CFG, a grammar, and you will have to build the PDA using this context-free grammar. Okay. So we are trying to, there is a theorem, I will not bother about that right now, but the theorem says that they are equivalent means what? For every context-free grammar, there will be an equivalent PDA and vice versa. Equivalence means that, right? There is an equivalent PDA, and tomorrow we'll see how to convert the other way. That is from PDA, how to convert it into grammar. Today we are doing building PDA from CFG. Very, very simple. There are two methods, of course, how we can build a PDA from CFG. One method is called as top-down parsing, and second method is called as bottom-up parsing. Both are very simple. As the name itself tells you, top-down means we'll start from starting symbol and work downwards. Downwards means we'll go and check whether a given string can be generated from that starting symbol or not. And in the bottom-up parsing, we'll do the reverse. That is, we'll start with strings and we will move towards the starting symbol. So here you are starting from starting symbol and moving towards the string. Here you are starting with the string and moving towards the starting symbol. That's why bottom up and top down parsing. Okay. Basically both will tell could the grammar generate W. W means string, right? So basically it answers could grammar generate some string, let us say W. Alright. So I'll directly start. As I said, I'll skip both the theorems and we'll just see the problem. Okay, easy ones. We'll see the problem. We'll take one grammar and we'll see how to do it using top down and bottom up for the same grammar. Alright. So you already know one grammar that we have used for expressions. Right? We had written a grammar for expressions. So how did we write the grammar for expression? The grammar included the symbols E, T, F, ID, plus, even for past tree use this grammar, closed bracket and open bracket, right? These are your states and symbols that were used. So how did the grammar look like? Yeah, of course, out of which ID plus star and these were these are the terminal symbols. These are the terminal symbols. This is a set of terminal and non-terminal symbol, and you have rules, and the starting symbol is E. Okay. So how did the rule look like? R is equal to, and this is the grammar which we wrote after removing the recursion. So E derives E plus T first step, then E derives T, T derives T star F. I am writing it in a single line. Yeah? Hello? Somebody please mute.
No.
T derives F. Who is that? Please mute. Yeah, thank you. And F derives E, and also F derives ID. Right? This was after removing the recursion, we had written this expression. E derives E plus T, E derives T derives T star F, T derives F derives E, and F derives ID. Okay. So using this example, we'll design two machines. Okay. Which accept these expressions. We are going to design two machines, one using bottom up method, one using the top down method. Okay. So let us first write, okay, let us say CFG to PDA, and let us start with top down approach. The input to this top down approach will be the grammar, okay, and this is the grammar that we are going to use. So basically we are going to convert this grammar into PDA. Simple procedure to do this, okay, to build this. The first step will be, we'll always start from a particular state, okay. Let us say P. It's always like that. We start from a particular state, and as I said, I'm doing top down, remember. And from this state, what we'll do is, we'll just push the starting symbol. In this case, E is the starting symbol, correct? So push this starting symbol and change the state to some other state. Let us call it as Q. And remaining everything we are going to do in Q. Okay. Here whatever is there, I am going to write it below here. Okay. But everything else we are going to do in Q state. This is the first step, okay. So given grammar, you are converting it into a PDA. To convert it into a PDA, we'll start with the state, let us call P, and you see, it doesn't matter. You are doing nothing. You are just pushing E onto the stack, and you are moving to a state called as Q. And everything else you are going to do in that state called as Q. So what are the various things that we are going to do? So this is a PDA, isn't it? So let us write the transitions, delta transitions, capital delta transitions at this point, okay? I think we'll get some 10 to 11 transitions at that stage. So let us write all those. So first thing is E has to be replaced with E plus T. Means each time in stack whatever is there, that will be taken as the left hand side and it will be replaced with the right hand side of the expression. It's top down, right? So suppose I want to generate ID plus ID star ID, something like this. You remember this drawing the pass tree. You start from here, then you expand to E plus T, then you replace this E by T, and that T will be replaced by T star F and so on, isn't it? The procedure. So same thing, what we are doing is we are starting from E and we are trying to see whether this can be derived using a particular grammar that has been given to you. Alright. So in the stack, what we did, we pushed E first. All right. So what are the other things that will happen? You can see everything will happen from state Q itself. So let us say you are in Q, okay, and in the stack you have E. You only pushed E into the stack, isn't it? So first step is, if you have E in the stack, what to do? If you have E in the stack, okay, that E has to be replaced as E plus T. E has to be replaced as E plus T. Okay. If E is there, replaced it with E plus T. Next, let us take this. or if you have E, you can choose to replace it by T, isn't it? For E being left hand side, you have two right hand sides. All right. Next, or when you have next to this one, if you have T on the left hand side, that is in stack, if you have T, then that T will be replaced as T star F, right hand side. Okay. Or the T can also be replaced by another right hand side, that is F. Okay. Next, if F is there, that can be replaced, sorry, if F is there, it can be replaced by E because F derives E, correct? Or else it's not just E, it's a E inside the bracket, correct? It's an E inside the bracket. So you can replace that F by E inside the bracket, or you can replace it with an ID. Grammar is here, so you can replace it with an ID. So this is how you replace the symbols inside the stacks. Okay, so you can replace it with the ID. So I have replaced every left hand side by the right hand side. This is first set. The next set is to see whether I can generate this. Ultimately, for every input that I get, I should also have this inside the stack. I can match them and pop them off. Ultimately, the stack has to be empty to accept this. So matching with the stack content and popping off, how I will do? It's again quite simple. If the input you got is ID and if you have ID inside the stack, just pop it. Okay. Matching, all matching. What other symbols I have? If I have open bracket in the input and in stack also I have open bracket, then just pop it. Correct? Similarly, what else I have? Closed bracket. So if you have closed bracket in the input, closed bracket inside the stack, pop it. Right? Similarly, ID is plus and into, right? So if you have plus in the stack and plus also in the input, pop it. And if you have star inside the stack and star in the input also, you pop it. Okay. So these are the instructions and this is how you do top-down conversion from CFG to PDA. I'll repeat again. You will be given this grammar and we know that there is an equivalent PDA for every CFG. And how do I do it? So in stack, initially what we do before we start, see the question that we are going to answer is whether we can generate some string. Okay, whether we can generate some string. That's the question we are going to answer. So how do I know whether this language accepts or generates a particular string? So if you have been given a string like this, let us say ID star ID plus ID. This is your W. You are trying to see whether the PDF generates this, right? To do this, we are taking help of the context-free grammar. Initially, we are going to put, and this is bottom, top down. Top down means we'll always start with the E. We'll always start with a starting symbol and E is the starting symbol for this grammar. So we are starting with E. Okay. So that's the first step. Doesn't matter what's in the input. Usually nothing will be there yet in input or stack, or it doesn't matter. We are just going to push the E into the stack. Okay. After that, you can see if this is there in the stack, it will be replaced with this. Right. You can see here, input doesn't matter at all. Whenever I am pushing or replacing the content of the stack, input is not mattering. So if E is there in the stack, replace it with its right hand side, E plus T or T. Okay. Similarly, if T is there in the stack, if you need to replace it with the right hand side, that is T star F or F. Similarly, if you have F in the stack, replace it with open E closed or even with ID. So this is stack replacements. Next is, we are trying to see whether this input can be generated, right? So inside the stack now I have to match. By using something I would have replaced some symbol with ID. I can replace most of those symbols with ID, correct? So non-terminal by a ID terminal symbol. So here what you are trying to do is, whenever you get a symbol, for example ID, you are trying to see if it is also there in the stack. This is input and stack. We are popping, that means what? It's matched. So if you have an input symbol, for example, open bracket somewhere, and in the stack also there is an open bracket. So you might think, where in the stack open bracket, how did it go? You remember this, no? That is here. You only have pushed open bracket, E and closed bracket. So open bracket and E, closed bracket are also pushed. So if you have an open bracket in the input and also open bracket in the stack, you are going to pop. So basically you are matching, whether it's a closed bracket with closed bracket, plus with plus, or into with into, all of those we are going to pop. Okay. So this is converting a given CFG to PDA using the top-down approach. The next approach is how to convert the CFG to PDA using bottom-down approach. Bottom-up approach. Using bottom-up approach. Okay. So of course, in top down we started with the starting symbol and move towards the W. In this case, it's going to be reverse. Okay, it's going to be reversed. We are going to start with the W and we are going to see ultimately in the end whether we have reached S. So what are the steps for this? Very similar to the top one, slightly different, so don't get confused. Again here, as a first step, okay, we'll be in P, just observe this diagram here once. You were in P, no other transition in P, only transition was pushing stack and going to Q, and rest all the transitions were in state Q. Here it is reverse, okay, here it is reverse. All the transitions will be in state P, and ultimately to go to the final state, only one transition. The transition is, you should ultimately have only E left. That is, from W, you would have reached E. Okay, so you would have reached E. Only in that case you will make a transition to final state. So what are the various transitions that we are going to do? So I'll just rewrite the grammar. It will simplify job for us. So the grammar was E derives E plus T or T, and T derives T star F or F, and F derives open bracket E closed bracket or ID. In simple terms, these were the grammar symbols. Okay, these are the grammar symbols. So the first step here is, if you are in state P, and let us say your input is ID. I told you we start with W. In earlier case, we started with S. Right? Here we are starting with the input directly. So if your input is ID, okay, so you are going to push, doesn't matter what is there in the stack, you are going to push that ID. Similarly, if you are in P and you get an open bracket, doesn't matter what is there, you are going to push the open bracket. So if you have a closed bracket, doesn't matter what is there, you are going to push the closed bracket. Okay. If you are at P, let us say you have plus, doesn't matter what is there, you are going to push that plus. Similarly, if you have a star, doesn't matter stack content, you are going to push the star. Now see, it's exactly reverse to what we did here, isn't it? Here you can see when the input and stack contents matched, we popped all of them, right? In top down. In bottom up approach, whenever you get a terminal symbol, you are going to just push it. All right. Next, here what you did in Q. See, in Q, when you got E left hand side, you replaced it with the right hand side, correct? You replaced it with the right hand side. Now that will also slightly change here. For example, now if I'm going to take the right hand side in reverse. Right hand side in the reverse. Okay. For example, here the grammar symbol is E derives E plus T, correct? The grammar symbol is E derives E plus T, isn't it? This is the grammar, right? Okay. So this is the grammar. So when I write the push options now, you can see here, if in stack you had T plus E, why will you have T plus E in stack? See, when we push this E, replace E by E plus T in stack, how will it look like? E plus T when you push, right? From the stack, when you see, it will be T plus E, right, on the top. You remember the push option in PDA, isn't it? Whatever is pushed in the end will be visible towards the left side. Okay. So you will replace this T plus E by E, this one. Okay. Similarly, if you have T, you will replace it with E. Okay. Now you will replace F star T by T, and you will replace F by T. Okay, and you will replace this, that is open bracket E closed bracket. When you push them, how will they look? See, open bracket E closed bracket. So when you see it from there, it will look closed bracket E and open bracket, right? When you see the stack content, closed bracket will be here. So you will be replacing this by F, right? And also you will be replacing an ID by F. This is how we convert a given CFG into, these are all PDA expressions, isn't it? Into a PDA. Okay. And this conversion is done using bottom up. So in bottom up, you can see we start with the terminal symbols. All terminal symbols are simply pushed, correct? And non-terminal symbols, right hand side is replaced with the left hand side. And every transition happens in the starting state. And final state you go only if I have in the input after replacing everything, I have only E. That is, you have reached the starting symbol for this grammar. And if you take top down, you can see all terminals are popped and you get matching. Otherwise, replacement in the stack is in the reverse order. That is, left hand side is replaced with the right hand side. Okay. So I'll stop for now. In the next class,